Friends, welcome to the session on machine learning. So we were talking about some sort of algorithms, and if you consider those kind of the algorithms in the machine learning, we have seen k-nearest neighborhood, and thereafter we have seen some naive Bayes, and thereafter the support vector machine, and then latest we have seen decision trees. Okay, so these algorithms we have seen in the earlier session. And of course, the KNN based on the distance measure, okay, or distance calculation, it is going to perform the activities. Naive Bayes, okay, so it is based on the Bayes theorem, and all the weak learners can be embedded in this particular Naive Bayes. Support vector machine is something like which is to handle the n-dimensional data into some two-dimensional logical format. And moreover, the idea is the support vectors, okay, and as well as the maximizing the margin, and moreover the kernel trick. All these things we have studied, guys. And in terms of the decision trees, we have seen some sort of tree-based architecture, and of course the main advantage of this decision tree is any data type, any kind of the data can be handled by the decision tree, no matter whether that is the continuous data or categorical data, whichever. And if you are referencing the other models, like along with these kind of thing, it is supporting both classification and regression. Okay. However, we are limiting ourselves to the classification, and at a certain point of time, just we can make use of these decision trees for regression also. We'll see once we complete the classification, friends. Okay. In the discussion of the regressions, we'll talk about those kind of support vector regression, decision tree regression, all these kind of the things. We'll visit them. Now, in the decision tree, if you remember, there is a node split. The main important aspect is node split, where we have seen some chi-square, and as well as some sort of information gain, okay, and some entropy computing. These things we have observed. So based on that particular thing, the algorithm decides which node to split according to the measures we get. And apart from those kind of the conventions, now the most commonly used algorithms in the landscape of the machine learning algorithms is the random forest. Okay, so I can say, suppose you are a initial member who are interested to learn the machine learning, or who want to implement some sort of the algorithms, then you can go and make use of this random forest. So reasonable accuracy on the corresponding data set. And moreover, this is a panacea. Panacea means a solution for all the problems, a common solution for all the problems. Like, though you are not having that much capable of handling the appropriate data or processing the data, but still you can have this random forest kind of thing, and where it is really helping you to get the minimal accuracy, reasonable accuracy. Okay, so this is the most important and exciting part related to the random forest. So, and let me pull some kind of the data for you guys. So, because at the moment we are talking about the random forest and all these kind of the things, there are certain points we need to observe. where many at times, which is used to handle some certain aspects. Like in terms of the decision trees, we come across with certain points so as to perform the activities of variable importance plot, all these kind of things, and which is used for both classification and as well as the regression. Similarly, here, just if you observe the notion of understanding the random forest, as that of the decision tree, because in fact, random forest is the combination of the decision trees. Okay, so if multiple decision trees are combined and it is formed as a random forest kind of thing, as the name suggests. So just if you refer the kind of the convention where one can elect the appropriate decision tree, and all these kind of the decision trees were integrated. Okay, the integration of these decision tree and all those things can be considered. So likewise, classification, regression, and performing the missing value imputation. Most importantly, guys. Okay, because the advantage of this machine learning algorithms is that they are not only used for prediction or some sort of accuracy measure and all. Apart from that, they helps us to achieve some byproducts like missing value imputation and outlier analysis. Okay, so which is a very important problem we generally face in the understanding of the algorithms. And apart from that, we're having the dimensional reduction. So the most important thing is, suppose I'm having feature 1 to feature 100 in my data set. So generally data sets are all in format. The data sets are not in format and they are all comes under different shapes. And it is a data engineer or machine learning engineer need to take care about how do I manage the things and how I need to perform the activities by reducing the dimensions. And in fact, the curse of dimensionality, most of the blogs and most of the textbooks, if you go through, curse of dimensionality. What it refers is, guys, suppose if my data set is having numerous or a number of dimensions, then in that particular case, there are certain limitations. I mean, I cannot process all the 100 or 200 number of the variables or features, and I may end up with some kind of less accuracy and predictions. So definitely, reduction of the dimensions is most important point in the generation of accuracy and predictions in a better way. So in that particular case tense, you can make use of this random forest. Okay, I'll cover those things like missing value imputation, outlier analysis, and as well as dimensionality reduction. Okay, with respect to random forest. Okay, in another time. So just as we are first completing the understanding of the algorithms like classifications, and then we'll move to the regression algorithms. And once the regression is over, then we can handle this missing value outlier and dimensional reduction. All these are the pre-processing techniques. And in fact, we are getting some of the questions in the Databricks certification also related to this pre-processing of the data. So now the once this, if you observe the importance of the corresponding random forest classification regression, we know as that of the decision tree in a similar way, this random forest also giving us the opportunity of working with both classification and regression kind of thing. Apart from that, these 3 points are notable. Okay, outlier analysis, missing value imputation, dimensional reduction. Missing values are nothing but the null values, friends, so where the values are not known and they strongly influence the corresponding outcome and result of the appropriate model. So we have to handle them. That is, we are knowing that we are naming that thing as a missing value imputation. Somehow we need to catch hold of those missing values and we need to perform the activities. Outlier analysis is something like maybe if I am taking some example, earlier also we have seen some example in a company. So just I want to get how many persons has completed the certification. Maybe that is the university certification. Nowadays, universities are offering various certifications on data science and machine learning, or else any educational institute, any edu tech companies, or else Microsoft or Databricks or Oracle, something like that. So now we are getting the in a particular team, maybe something like data services, and we just picking up who are completed data engineering number of certifications, maybe across DE, DA, DS, ML, various subfields are there, various verticals are there. In DE, we are getting some five, and in DA, we are getting some 105, and in DS, we are getting four, in ML, we are getting three. Now you see, this is abnormal. This is abnormal. This is known as the outlier. Outlier is nothing but the data which is not in the expectation or in the limits or that I can say that is an abnormal data. Maybe if I am conducting some exam for 50 marks, maybe the capstone or something like that, and suppose in the evaluation somehow the data entry is 150, then it is outlier. Okay, because this 150 actual marks are 50, maybe 35, 40, 39, 43. These are all actual values. Apart from those things, if I'm giving the 150 as a mistake, that is outlier actual. Outliers are nothing but the faulty values. So those kind of things can be handled by the random forest. That is one more important thing. In dimensional reduction, already I have given the notion where you can observe the point of maybe abnormal number of the dimension if I'm having, and if I want to limit myself, if I want to perform the activities related to those kind of the conventions, I can clear 1 minute. Sorry for that case. Okay. So if you are referencing the other things along with the advantages, the main important thing is understanding the concept behind the random forest because in our earlier sessions also we are focusing on what is the mathematical model related to that and how we can handle those conventions. And here there is a point raised actually. Because as I said earlier, no, before starting of the section, KNN is a distance measure. Naive Bayes is a weak learners and all. And your the support vector mission is dimensional based on the dimensions and margins and kernel space. And if you are referencing the tree kind of thing, which is having the chi-square, information gain, entropy, all these kind of things. Whereas your random forest is up to now we have not seen any specific criteria. Okay, but there exists some sort of the criteria related to this random forest. So now we'll be discussing that. So far we have seen just which are all the aspects related to the random forest, like classification, regression, which is really helping us in missing value imputation, outliers, dimensional reduction, all these things. But apart from that, what is the model behind that? Okay, so random forest is like bootstrapping algorithm with decision tree model. So bootstrapping is a concept, guys. Like where if I am taking some data, okay, it is picking up that particular all portions of the data, and it is coming up with coverage. All these aspects, whatever the source data I'm having, all that particular source data will be covered and handled. Whereas if you are referencing the other kind of thing, I'm having 1,000 rows and 10 columns. And rows are never matter there because if I am having the huge amount of the data, then it is always good. Okay, but dimensions wise, we need to take care. Because if a number of columns are abnormally increasing, then obviously we'll end up with some. Of course, these particular columns are causing some trouble and which are negatively contributing. Okay, in some times. And if you are referencing the 70 percentage of the data and 60 percentage of the variables, that means Out of 1,000, I'm taking the 700 rows, and 60% means six columns. So likewise, I'm taking the decision tree one, decision tree two, decision tree three, and all these things were integrated so as to form the random forest. Okay. And there is one more concept called, actually, there is a concept called bagging, and as well as the boosting kind of thing, guys. Okay. So bagging and boosting, there are two ensemble kind of. In fact, our random forest is an ensemble model. Okay. So most importantly, what do you mean by this ensemble is integrating. Okay, integration of multiple algorithms. Okay, so that means algorithm one is there, and I want to mix the algorithm two, and I want to empower the model. I want to empower the model. Now, if you refer the orientation like this, guys, suppose if I'm making use of the convention of decision tree one, actually this is a algorithm one, assume that. And same bootstrapping decision tree two on top of some data, this is algorithm two. Likewise, I'm having decision tree n number of things. So all these kind of things. Okay, integration, which is the format of the ensemble learning. Okay, which is the ensemble learning. So the main advantage of this random forest is it bootstraps. It performs the activities, the picking up of the data. It refers all the data items and all these kind of the conventions. Now let us move ahead. So if you are making use of this ensemble kind of the learning, and what is the how does it work? Because it's a pretty simple narration, like taking the data items or columns, all these kind of things. But how it is helping us? Because random forest is quite versatile, and any machine learning engineer can depending on that particular can dependent on that random forest, because it is having the minimal accuracy and prediction rates. So how does it work? Because this point is most important to us, and always I refer this point, guys. Like, though you are you need not by heart any definitions or all these kind of the terminologies, but you should know the what is the background of that algorithm. Okay, maybe naive bayes, knn, and decision trees or support vector machine, whichever we are talking, the essence of that algorithm. Because however, you need not worry about the entire implementation. You need not write entire code as that of the other projects. But especially in machine learning, we are having algorithms, and it is always straightforward using of those kind of algorithms to create the models. And but only the point is how a data scientist is clever enough to maintain the hyperparameter tuning technique. Okay, and how clever the data scientist is to manage the balancing of the data set. How clever the data scientist is to handle various kinds of parameters so as to get the best outcome. So this only defines, guys. Okay, how many certificates you are having or how many books you have read, that is fine, of course, which empowers, which give you some knowledge, but that knowledge should be converted into the intelligence. So the intelligent data scientist always not by heart anything. He is always sees the reality, and of course, based on that particular convention, he works. And at the moment he observes the data and he get the appropriate requirements from the client. Initially, he should able to pick up one or two algorithms. So we are having 10 to 15 algorithms roughly, but still, as a data scientist, you should be able to observe at a first glance. After seeing that particular data, you should be able to observe which is the best algorithm suits for my requirement. Okay, so because we know the data set and we are all aware of some sort of the data. Okay, apart from that particular convention, how these things can be helpful to us so as to empower the model. Okay, so as to handle the things intelligently. Okay, so moving ahead, if you are referencing this, how does it work? Assume number of cases in training set is n. Sample of n cases is taken at random, but with replacement. What do you mean by this with replacement? and as well as without replacement. Okay. Now you see guys here. Suppose I'm having some data, S3, S4, like that, S1000. This is the sample of the data. Then I need to generate randomly some sort of the data. First run, I have taken some S5 like this. With replacement in the sense, again, I am making use of some other things. So without replacement means maybe there is a repetition because we are not replacing the same elements may be repeated other time. But with replacement in the sense, once if I am getting the data, I should not repeat that particular data. Okay, that is what with replace. In both the cases, you can observe, guys. And here the m input variables, maybe the features, a number of m numbers such that each data. Okay, suppose how I am taking the rows, I need to take the columns also because as you know that all the columns may not equally contribute to the model. So in that particular case, it is always a trial and error method kind of thing. But logically, that's what I said now. Bootstrapping is a kind of the methodology where random forest can enjoy the coverage of all the rows and coverage of all the columns information. And accordingly, just you can make use of the convention, like how these set of the variables and process these number of rows and columns. And we grow trees to full extent on each one of the random subsets. As I said earlier, so first we are taking the data. Okay, this is one set. And related to this particular sample, we can make use of the corresponding columns information. This can be taken as a decision tree 1. And similarly, S4, S5, S6, and then we are taking some other columns information. This is another tree. Likewise, there is a possibility of generating all these kind of possibilities with the help of the bootstrapping, and they will be integrated to some random forest. Now, just observe this here. So if I am trained well, obviously I can perform well. Okay, that is a simple formula. So you are what we are doing is you are notifying the entire information about the data and as well as the corresponding patterns of this particular data to your model. Then your model is completely empowered. And so this aggregation of the results and majority voting means so just out of this particular thing, how many yes are there? Majority voting and for the regression, as I said, if you are referencing the decision tree and random forest, both are available in the fashion of classification as well as the regression. So here, maximum majority voting for the classification, how many S are there? And in the regression, we don't have any S no kind of thing. We need to have the value so that we can take the mean of those kind of the values. Remember, guys, maybe in terms of KNN or support vector machine, decision tree, random forest, in all these things, one commonality is there. You can use these algorithms either for the classification or regression. Remember one point, in terms of the classification, you need to observe the majority voting. Whereas if you are making use of these things for the regression, you can take the mean value. That is only the distinction. Otherwise, all the performance, all the activity, hyperparameter tuning technique, because it is the algorithm which is having certain kind of the parameters. Those parameters remain same no matter whether I'm using that algorithm for the classification or regression. In either way, it is making use of that particular convention. Okay. Now, with this, just we're having some sort of idea related to our random forest kind of thing. And what I'm doing here is I want to notify you with some sort of appearance of this random forest along with the kind of the notion, like which are all the advantages and all these kind of things. Have a look on this, guys. So now, if you refer the understanding of decision tree logically, uh, just you see here, guys. Okay, just I'm portraying this particular diagram just we are having some sort of the information. Okay, so just we are making use of tree one, tree two, tree three, like that, all these things. Out of that, just the best one, okay, whichever the thing, because we are handling this random forest kind of thing, where all the trees were bootstrapped and they can be used to identify the best prediction. Okay, so this is a simple narration. And advantages already we have seen, like in the earlier thing, apart from the classification and regression, I can make use of these random forest for missing value imputation, outlier analysis, and dimensional reduction. So these are all can be considered as the advantages. Apart from that, I'm having some more additional points in the study of the random forest. As said earlier, which can be used for both classification and regression, and decision tree classifier I'm having, decision tree regressor I'm having. Likewise, I'm having random forest classifier, random forest regression. Even support vector classifier is there, support vector regressor is also there. Variable importance plot. This I will give you some example guys, because variable importance plot really helps you not only in the implementation of the models but also in the data pre-processing. Sometimes if you want to understand the data, you have to pre-process the data. And for that, you need to observe, maybe you are having some thousand variables or features in your data, which may not equally help you to solve the issue, or to give you the proper narration of importance of that particular variable. So in that case, simply you can go and make use of this random forest for the highlighting of the contribution of the variables. And outliers, missing value imputation, and as well as outliers, as already I have mentioned, missing values and these. And outlier analysis is also one of the important things. And of course, with the help of the box plot, you can see the outliers with some support of the SMU. And directly, if you want to get the perform the outlier analysis, then you can go with the random forest. And this is helpful for the higher dimensions, like higher dimensions data. Suppose dimensionality is the curse of dimensionality, as always we are talking about, and get rid of overfitting, because this overfitting is another problem, guys. Like because decision trees also suffer with overfitting, and where our model is overly learning the training data, but at the time of the testing, it is not competing. Okay, so that is what we have seen in the overfitting. There, I have given some discussion on bias and variance. Have a look on that way, because bias and variance study is most important. So just to refer to the earlier sessions related to that overfitting and all. Now, with this, we are eligible to see the performance of these kind of the algorithms, because we were talking about some sort of algorithmic notation. But what I'm doing here is rather I can make use of the convention. Like just a minute, guys. Yeah, these techniques. If you observe this, guys, and I am trying to explain all these kind of the conventions. One is the k nearest neighborhood thing. Okay, so this see up to 22 lines, up to 22 cells. Just we are taking the pre-processing steps. I will be explaining them. So which is common for all, and then we move to the k nearest neighborhood, and we are estimating the appropriate accuracy. And then we'll move to the AUC ROC also, which is very important. And then we are seeing the naive Bayes, the simple example, and then we are talking about this section tree, and finally the random forest. Okay. Now, initially, just this is a cancer data where generally all these particular data are available in Kaggle and all these kind of things. And the most commonly used constructs are NumPy, pandas, and scikit-learn. And within that scikit-learn, we are having the pre-processing kind of the things, and we are reading this data, read underscore CSV, whatever the data set we are having. Now, head only just it is giving the first five rows, and tail which gives the last five rows. And what we need to do guys here, this particular ID, I am not interested. Okay, only that is what I said. As a data scientist, we should able to observe, we should able to observe which are all the constructs, which are all the things are initially not important. Because practically this ID and all not going to influence anything, guys. So that we are dropping that. So and then you can see what exactly the data is. And we may not practically, we are not subject matter expert in medical domain, so that we can see these things as it is. Okay, but these phenomena can be observed because at least you should know that malignant and benign, and this as we are using the this particular thing for the analysis of the classification, and there we need to find out whether that tumor is malignant or benign. Malignant is true, benign is false in the diagnosis. And value counts, how many are benign and how many are malignant. This is all to understand the data and summary of the data. And LOC and ILOC, guys, ILOC is nothing but if I need to follow the indexing provided by Python, then an index-based LOC. Whereas LOC specifies that with the names only you can refer. Okay, directly you can make. And describe and info are the two functions where you can study about all the description of the data. Because sometimes, to understand the data, like what is the mean, standard deviation, all such kind of the statistical measures, you can make use of this convention. And as I said earlier, index-based locations, according to the requirement, we need to generate the x and y values. X always refers to the features, y always refers to the outcome. Okay, so just we have differentiated those things. Now, just what I want to do is malignant is, as I said, true that patient is affected by cancer, and whereas zero is not affected by cancer. So two possibilities. So accordingly, just we are making use of the normalization, which is another important thing, guys. Suppose the problem with the machine learning algorithms is there is a problem of skewness. Skewness in the sense, suppose if I'm having some data with me, and if that particular data is every item, if I'm taking age, experience, salary, generally age, experience compared with salary or less values. Salary maybe 6 digit or 7 digit or whichever. Then the algorithm may feel that okay, this is maybe importance for me. This value is importance for me. So in that particular case, friends, it may overlook the age and as well as the experience, but we don't want to miss out the importance values due to the higher values, because it doesn't mean that higher values are not at all I mean higher values contribute, but it doesn't mean that lower values are not contributing anything. So that what we need to see is just we are having the process of the normalization where you can rescale your features to understand the data in a better way with that. And likewise, we are describing all these kind of things. And now the most important thing is like any machine learning algorithm, no matter whether I'm using the Python, PySpark, or whichever the model, I should split that particular data, because training data and as well as the test data are the most important aspects. Where your 75-25 or 80-20 kind of the rule always you can follow. Now you see here, friends, and this model selection, train test split we are importing, and these four terms are pillars of the evaluation: X train, X test, Y train, and Y test. So your X values all features, Y values are not nothing but outcomes. So what we are doing here is we are separating this into the train test split. Like your 80 percentage of the data is training, and 20 percentage of the data is a test actually. So these two are the things. And now training data, and there is observation of the test data. And these are all operational kind of things, friends, where if I want to convert those kind of things into the integers or required kind of the data, it changes from problem to problem. Okay, accordingly, just we can manage the convention enough. So all these previous steps are not going to affect any algorithm. That's what I'm saying. Your pre-processing, we started with loading of the data, and we try to understand the data and separating the XY. And after separation of that XY, again we are making use of the train and test split. These are all the natural kind of the process. And machine learning engineer or data scientist, before selection of the algorithm, he has to spend his time with the understanding of the data, to understand the data and to handle the conventions of the data. All these are the pretty common practices. Now, now you can realize that because in the KNN, we have seen that there is a distance calculation or distance measure kind of the thing, where with the cosine values or some sort of Euclidean distance, you can activate those kind of the distances. Now, have a look on this guys. We are not talking about any such kind of internals. Just I am making use of the k neighbors classifier. Just we are creating a reference of that thing and we are fitting. Generally, just to observe that fitting is nothing but model creation. Just we are training the model. Okay. And whereas your predict is nothing but the testing the model. So remember that fit is a method where you are going to specify the training phase. So for this particular training, I'm having explained and as well as the Y train. And for the prediction, the important thing is that we are not going to use the Y test, but X test we are using. And this data yields the Y prediction. That means your Y prediction, actually the point is your Y prediction variable should be compared with the Y test. The reason behind is this Y test is your real data. Okay, this is the Y prediction is nothing but your algorithm. Okay, predicted data. Okay, algorithm predicted data is nothing but the Y prediction. Now, after getting this particular Y prediction, and then you need to compare with this thing, and you are able to compute the corresponding whatever the accuracy values. Now, if you observe, guys, the accuracy can be computed with respect to the metrics. Already in the classification technique we have seen, like we are having some confusion matrix, AUC, ROC curve, recall score, accuracy score. All these are various scores where you can specify, and accordingly we can use. And out of the things, accuracy score is the uh, most important and dependable score. Now, if you refer this kind of the accuracy, so just I am having the 94.73, which is an excellent accuracy, guys. So with the KNN itself, we always say that KNN is something like a basic algorithm, and which may leads to the underfit of the data. But here, in terms of this particular data, what we have taken, this particular data, on top of this data, if I'm applying my KNN kind of the algorithm, it has given 94, around 95 percentage of the accuracy. Okay, and then confusion matrix, true positive, true negative, negatives, false positives, false negatives, all these kind of the conventions, these are all positive cases, 69 and 39. Only six misclassifications happen. So this is all depending on that's what I said, the capabilities of the data scientist not lies in by hearting or studying many things, but intelligently how I can make use of this knowledge into the implementation. Okay, and then I can see the classification report, which is involving precision, recall, F1 score, and support all these kind of the conventions. Now, the most important thing, guys, cross validation score, whereas min max and all these kind of the things I want to transform, because at times there may be a possibility of converting the appropriate information into the numbers between 0 to 1 or all these kind of things so as to normalize. So in this case, so as to come up with some cross validation score, just we are making use of three things: cross validation score and cross validation predict. And with respect to the model selection, I'm having those kind of the convention. Now I want to this cross validation. These are all hyperparameter, friends. Maybe you can alter these kind of things and you can observe that at what time, at what stage it has given the best possible outcomes. So your accuracy scores, okay, cross validation score is good in the second point where you can observe the maximum possible outcome related to this thing. And another thing related to the observation of the model prediction and advantage is AUC ROC curve. Okay, ROC is a probability curve, and AUC represents the degree of measure of the separability. The higher the AUC, okay, the higher the AUC, the better the model. That means just to remember that how our accuracy score is high, how our prediction rate is high. Similarly, your AUC must be high. Okay, then the model is good. The closer an ROC curve is to the upper left corner. See here, this is the curve, ROC curve. If it is moving to one, then I can say, okay, more efficient. But one more important thing, always there is a problem, guys. We cannot say that my accuracy is good and I am not overfit. We cannot say that, and it is all responsibility of the data scientist to travel ahead with the data and as well as along with the hyperparameter tuning. Then only you can still there is a chance of erroneous kind of the conditions. And in that particular case, adding up the more data or adding up more dimensions, which earlier you left with, all these kind of the things definitely give you some sort of understanding how do I perform the activity. And my ROC score is 93 around. And guys, especially in this particular data, KNN is really performed well because generally it crosses 80, 81, 82 like that only. But now, especially in this example, you can observe this 94 something accuracy is noted by the KNN. Moving ahead, now you can observe how do I implement the naive Bayes, the same kind of the convention from SKLN, just importing the Gaussian naive Bayes, and here as well the creation of the reference and then fitting of the model, and thereafter the prediction. So now if you observe the prediction score similar to KNN, generally naive Bayes, if weak learners are there and if any textual data is there, and if I want to perform some kind of the NLP kind of things, for that Navigaze is really good algorithm, guys. In this particular case, both KNN and Navigaze are almost registered the similar kind of the accuracy. Okay, and then precision and all these kind of the actually precision score is good for the Navigaze compared with the KNN, and ROC value also 93.33 as that of the thing. And similarly, if you are referencing the confusion matrix also, here also we are getting the same approach. Only six misclassifications happened in case of Naive. That means we have done excellent data pre-processing. That's what friends I'm saying. Algorithm remains same and your parameter remains same. And how good you are in the data pre-processing, then it reflects in the implementation of the algorithm also. So that obviously, and 70 percentage of data scientists or machine learning engineers should spend to understand the data and to pre-process the data. So accordingly, the appropriate reflection would be there. And see, if you are able to process your data in a better way, pre-process your data, then even simple algorithm also can able to give the better results. That is the advantage and beauty. And these are all the things where a byproduct kind of thing, friends, and you can go through. But again, our discussion is related to the algorithmic notation. So here also, just we are making use of the import. Here, as I said, I'm using the decision tree classifier, not the regressor, and creation of the reference and fitting of the model. And thereafter, the cross validation. So just the cross validation allows us to exchange the data and as well as perform some kind of the usage of all bootstrapping and all. And here in tree itself is performing the bootstrapping, okay, getting all the possible conventions and all. Now you see here X-train and as well as the Y train with cross validation. I am using the score as accuracy score and predict probability based kind of the method. Methods can be varied. So just you can change that particular methodology. And I felt this thing is recorded the best prediction, so that I kept that particular thing. You can change that methodology also, whatever the thing. Now, if you refer the accuracy score, I'm having the accuracy score as 91, which is surprisingly less than our KNN and as well as the naive Bayes, recall and as well as the ROC. Okay, all these things, and even this particular misclassifications are more in the decision tree. And there is one complaint with the decision tree, guys, like overfitting, because that is what it is. At the moment you are trying to train the data, it is very good. But whereas if you are making use of some testing and it is there, it's prone to the, especially in our case, this is sixth actually in KNN and everything, but now it becomes 10. 10 misclassifications are there in this. Okay. And similarly, the another algorithm where you can observe the random forest. So as I said, ensemble learning, where random forest classifier we are using, and here always the maximum depth, number of chains, all these things we have seen in the discussion of the decision tree. Similarly, here also you can make use of these kind of things as the parameters. And this is your classification reference. Just we are fitting the algorithm between X train and Y train, and we are making use of some sort of predictions related to that, and then the appropriate values related to the random forest. So just you can make use of the convention. It is outperformed case. As in the beginning of the session we have seen, if you are observing the random forest kind of the things, random forest generally registers high accuracy rates compared with the other algorithms reasonably. Okay, so in case of neighbors, we have seen some 94 and KNN also 94 and decision tree only 91 something. Now, if you see, random forest has crossed over all the other algorithms. It stood first in the accuracy model, and moreover, the misclassification also reduced to 4 because earlier it is 10 in decision tree. In KN and nowadays it is 6, but whereas now it is only 4 misclassification. So, uh, in that case, it is not only the performance of the algorithm, but also we need to focus on some particular points like the pre-processing techniques and all these things. If you are unable to understand the data, if you are unable to pre-process the data, then definitely your algorithm, because algorithms are fixed, guys. Algorithms are fixed, and it is the model which decides the efficiency of the algorithm. And model, I mean to say that there are combinations of pre-processing and as well as missing value imputation, dimensional reduction, all these all these kind of approaches, hyperparameter tuning techniques. All these are most important. Okay, so moving ahead to conclude. So if you are referencing the appropriate aspect in the understanding of this any kind of the algorithm, especially if you refer as a kind of the conclusion, KNN and naive Bayes registered around 94.7 accuracy, whereas your decision tree could able to register only 91 percentage, and random forest, of course, registered 96.34 something percentage accuracy. Now, the KNN is most basic algorithm where it is generally it's a lazy learning, and we can say this as instance-based learning. Okay, so here there is no learning actually, but still with the power of the data pre-processing. This is the most important point we have to observe. Power of data pre-processing. What do you mean by the power of data pre-processing? First is understanding the data. Data must be understood. Second important thing is handling of the missing value. That is missing value imputation. This is the important thing. Now, another thing, guys, here feature scaling, and thereafter encoding. Encoding means friends one had encoding, dummy. Okay, all these kind of thing, and uh, another transformations like transformations in the sense like you need to handle this thing, train test split, and most importantly, dropping the unused or unimportant dimensions, because unnecessarily these things create some troublesome. Okay, so because the algorithmic rotations, if you refer, guys, those they remain same more or less after a certain period. Just we will be getting some confidence on the hyperparameters and all these kind of the conventions. But whereas your 70 percentage of the success, especially in the machine learning algorithms, revolving around pre-processing only. So how do you handle that feature scaling, missing value imputation, encoding, transformations, and most importantly, you need to understand your data. Accordingly, we have to drop the appropriate value. Sometimes, especially in this particular data set, as we're dealing with the cancer data set, ID is not contributing anything. But sometimes, the in terms of employee appraisal, definitely ID I should keep because to whom I need to link that appraisal. Because at the end of the appraisal policy or appraisal system, if I am not getting the employee ID, then there is no use. But this ID is different here. Okay, maybe the ID of the data, I mean, that particular row or something, that is no use. Even if employee serial number is no use, but ID is very much important because in all our communications, we are not seeing anyone maybe in Zoho or in any other portal, Great HR, all these kind of things. So just we need to refer the member with ID so that we can get all his contact and suppose if immediately if I want to convey some information to Teams or something with ID I can without fail I can get that. Okay, so and these things are really unique. That is the most important way of reaching the appropriate member. Okay, so the key takeaways from the session before winding up. So just we started with the understanding of random forest, and this random forest is the ensemble learning. Okay, and the basis behind this thing is the bootstrapping, and most importantly, your random forest is the combination of multiple decision trees. So obviously, you will be getting the best accuracy. Okay, and again, apart from this, a random forest helpful in the classification, regression, missing value imputation, and thereafter dimensional reduction. Okay, and variable importance plot. All these kind of the things can be observed. And then we have seen the implementations of KNN, uh, name base, decision tree, random forest. Okay, so random forest, of course, as we are always keeping like outperformed along with 96.34 accuracy, better accuracy. So just it all depends on your data pre-processing and all these kind of the conventions. And in the next session, okay, what I want to start is the regression trends. Okay, in that regression, we'll try to give you the simple linear regression understanding and then multiple linear regression and try to give some case study on polynomial. But apart from that, don't get confused, guys. One more classification technique we are having that is the logistic regression. Though the name regression, but it is belonging to the classification. The reason is simple, yes or no kind of the computing it is giving. And apart from that, most importantly, we are getting some kind of ML questions in assumptions in regression techniques. Okay, these points I will try to cover in the next week. And if any specific ask is there, just you ping me so that I can scope those kind of the things also. Okay.